Copyright 2014, Math Diagnostics and Intervention, all rights reserved. Students seem to struggle with similar triangle problems when the triangles overlap. The easiest way to solve triangle problems like this is usually to separate these triangles into two separate triangles and then take a look at the problem. So let's take a look at this. Let's separate out our triangles. So our first triangle looks something like this. The smaller triangle has side lengths of 10, y, and 18. We have one congruency mark for this angle, which is angle B, and we have angle C at the top and angle D on the right. And then the larger triangle is A, C, E. We have one congruency mark in A. We have a side length of 27 for side length AE. We have a side length of y plus 7 for side CE. Some students have a hard time seeing that, but if you take a look at that length, there is y, and this length here is 7. So the whole length between C and E is y plus 7. So that's why we have y plus 7 as our length for CE. And in a fashion that's almost identical to that, we find out that AC is equal to x plus 10. So let's get the right color and say we have x plus 10 here. And the reason that's x plus 10 is because BC is 10, AB is x, so the whole length of AC is going to be our x plus 10. So now it looks like we don't have similar triangles. We only have one tick mark for A and one congruency mark for B. I don't have a second angle that's congruent. However, I do have angle C, which is congruent to itself. That angle there is this angle in both triangles, and any angle is congruent to itself, so angle C is congruent to angle C. So now, by angle-angle similarity, I have those two triangles similar. Now we have to find our scale factor. Looking at our triangles, the two sides that have numbers attached to them that we can use to write a scale factor are 18 and 27. 18 is between our one congruency mark and our no congruency mark, and 27 is between our one congruency mark and our no congruency mark. So our scale factor can be written as 18 over 27. I'll write that in lowest terms as 2 over 3. I could also use the reciprocal of 27 over 18 if I wanted to think about the large triangle to the small triangle. I could also write that in lowest terms as 3 over 2. Any one of those four scale factors will be acceptable. Now we're ready to solve for our missing values of x and y. I'm first going to solve for x. I'm going to say that our scale factor is going to be congruent to, let's use 2 over 3, is going to be equal to 10 over x plus 10. One fraction equal to another fraction, we can cross multiply. So I have 2 times x plus 10 equals 3 times 10, or 2x plus 20 equals 30. Subtract 20 from both sides. We get 2x equals 10, divide both sides by 2, and x is equal to 5. We can also use a method like that to find our value for y. This case here, I'm going to have the small triangle of y over the large triangle of y plus 7 is going to be equal to the small triangle of 2 to the large triangle of 3. Cross multiply, we get 3y is equal to 2 times y plus 7. Distribute the 2 in, we get 3y is equal to 2y plus 14. Subtract 2y from both sides, and y is equal to 14. So when you have overlapping triangles like we have in this problem here, most often it is easier to solve if you separate it out into two separate triangles like we did here. Find our scale factor and then solve for our missing values of x and y. Again, manage the details, find the scale factor, use the scale factor correctly and consistently, and you should have few problems with this similar triangle problem. Good luck!